Hello, we are Biomedical Senior Design Team 3, and our project is the Hospital Washer AutoSampler Phase 3, sponsored by Stryker. A little bit of background on our project. All medical tools used in surgery need to be properly washed and sterilized for use. This is done using industrial-grade washers as seen on the right of this slide. These environments come with a high variability that can lead to potential damage or unsterilization of the equipment. Our project hopes to tackle this issue by allowing technicians to view the data of each cycle in real time. Our group is a Phase 3 team working on this design. The first phase worked on creating the waterproof housing of the device as well as the sensor bases used for collection. The second phase solved the water ingress issue with the container as well as set up the infrastructure for the data to be collected. Our team's goals were to implement a code that allows for real-time data visualization with repeat viewing capability, as well as determine the accuracy of the sensors within the prototype. Moving on to our application, here we have the home screen with the two options to either go to a new cycle or view past cycle results. Let's start by viewing the new cycle. From here we have our cycle information page in which you're able to input a name for the cycle detergent location, as well as set up a cycle time. If you wish to revert back to default values or reset all the values, you have the option on the right. Moving on to the real-time data screen, you can see that the names that we input are listed here at the top. Once we hit start, the code will begin graphing real time. From here, we're able to flip in between each graph individually, as well as view the current value on the left. If you wish to end the code without saving a CSV file, you can hit the cancel at the top, or if you wish to finish the cycle and have it save a CSV file for later viewing, you hit finish on the right. Let's move on to the View Past Cycle Results screen. From here, you're able to load any of the previous CSV files done from real-time runs. We just chose the one that we just ran in the real-time demo. At the top, you'll see the 4 naming inputs that we originally set. From here, you're able to flip in between the 4 graphs. The only difference here is that you can zoom in independently on each graph and move the graph around. And then when you're done, you can save the figures separately from the entire program.
There were 3 main tasks to ensure the accuracy of the prototype sensors. Data was collected from a range of buffer values for each pH, conductivity, oxidation reduction potential, and temperature. This involved testing 10 points, distributed across the determined range, and taking 36 measurements at each point in the range. This process was repeated with a Mettler-Toledo transmitter as a reference unit, given to us by the Stryker team. Lastly, analyses of each dataset were done to compare the accuracy of the prototype against the reference unit. The accuracy and precision are calculated with the equations shown below. Accuracy is 100 times 1 minus the measurement error over the expected value, where the measurement error is the expected value minus the measured value. The precision is the standard deviation of the mean. The accuracy results calculated based on our data are shown in the table. ORP accuracy data is not available at this time due to standard solutions being delayed because of supply chain issues due to COVID-19, but it will be included in the final report.
To summarize, here's some of the milestones we've achieved over the course of the year. We determined general range of attributes within the wash cycle. We collected and compared prototype data in comparison to the reference unit. We analyzed and assessed data points of all attributes. We achieved a real-time graphing in a user-friendly GUI. We achieved the ability to save all the data in CSV files, and we achieved the ability to load the previous data into a GUI for viewing. Here's some of our acknowledgments of people that have helped us make this project possible.